Welcome to the Security Plus Testable Objectives. This first section is mitigating threats, and I'm going to break this down into two sections for you. The first section is performing core maintenance. The second section is managing viruses and spyware. And then the second half, which is going to be in its own section, is securing web browsers and identifying social engineering threats. So let's go ahead and jump right into the first section, core system maintenance. Okay, I want to talk about some of the primary causes for compromised security. And you can break this section down into technology weaknesses, configuration weaknesses, policy weaknesses, or human error and malice. In the first section, we want to talk about technology weaknesses. For example, protocols were designed to function. They weren't necessarily designed to be secure. So most considerations for security were really an add-on or an after effect. TCP/IP has a few well-known inherent weaknesses. For example, one of the protocols, ICMP, or Internet Control Messaging Protocol, that is used to test connectivity between devices, among other things. But what you can do is you can set it to terminally do what it's supposed to do, which is the terminal ping of death. There's also advanced attacks like Smurf and Fraggle. A Smurf attack is really an ICMP attack where you ping the broadcast address, therefore amplifying the attack, but also you spoof your source address because you don't want that traffic to come back to you because you're amplifying it. So you replace your source address with an address on the destination network. You can also increase the packet size as well. Fraggle is just like a Smurf attack, except it uses UDP, User Datagram Protocol, as its transport. Also, operating systems within themselves, they are known to be vulnerable. Part of the way software works is vendors will try to rush to market with a product as quickly as possible. Therefore, time is money. But what they'll do is they'll offer to support that product for life. So the model of business is changing. We used to buy things and we wanted a pristine product and we took care of it for life. That's really changing nowadays. You buy a product knowing that you're going to be serviced with upgrades inevitably. I mean, if you think about it, when you buy an automobile, do you buy an automobile knowing that it's going to be serviced for the rest of its life, or does the service contract really run out very, very quickly? And of course, it runs out very, very quickly. Software, on the other hand, turns that model upside down. Vendors will support it for the duration of the life cycle of that product. So there are well-known software or operating system vulnerabilities. And you can go to any one of the major advisory sites and do your little homework to find out if your operating systems are vulnerable or not. And then there's the networking equipment themselves. It doesn't matter if you're using a hub or a switch or a router. Each of those appliances have inherent vulnerabilities with them. I'll just give you a few examples. With switches, you have to worry about ARP poisoning or MAC address spoofing. With routers, you can defeat the access control lists, or you can spoof traffic. Or it may be the difference between a stateful versus a stateless router with access control risk. We're going to get into a little bit more of that later on, but right now I just want to illustrate that you can look at weaknesses in terms of technology weaknesses, and of course the next one will be configuration weaknesses. But before we go on, I want to point out here to the right I have the local area connection properties dialog box where you can go to your TCP IP properties. I'm a big fan of the checkbox on the bottom, show icon in taskbar when connected. I think it's very informative for the user. Okay, so the next section is configuration weaknesses. First thing I want to talk about with configuration weaknesses is unsecured user accounts. These could be accounts with generic usernames or passwords. You can go to the internet pretty much right now and just search for default usernames and passwords, and within a few clicks you will find a list of well-known default usernames and passwords. It could be a default password account with a default username and password, but it could also be just an account with a weak password. The next one I want to talk about is weak passwords. What really makes a password weak? According to me, it's if you can break into it or not, either through brute force or through a dictionary attack. If you can take a password cracker, analyze the passwords, and it breaks it in a relatively short period of time, to me that makes it weak. Some things that countermeasure that are having passwords that are at least 8 characters and a combination of uppercase, lowercase, numbers, and special characters. That will help countermeasure a naturally weak password. The next one is misconfigured internet services. Just to give you one example of a misconfigured internet service would be something that you would access through your internet service provider. You have mail, which is Simple Mail Transfer Protocol, or maybe you're using POP3 or IMAP to download your mail. Well, how are you authenticating to those services? Are you doing it in a clear text? Because if you are, then anybody can eavesdrop on that connection, and therefore you're disclosing what you would normally think would be private. Unsecured default settings. There are many times we can just go to a router or a switch and we can connect to the management interface or console of that, or we can connect to it with the simple network management protocol settings and get a lot of information from a device simply because it had unsecured default settings. Also, misconfigured networking equipment. Just to give you an example, on a switch you have something called VLANs, or virtual LANs. Well, there's the DTP, Dynamic Trunking Protocol, and this allows users to dynamically jump VLANs where normally you would need a router to do that. So that is just one example of a service on a network appliance where if you have a service like DTP or Dynamic Trunking Protocol enabled, that could allow users to do devious things. The next one is Trojan horse programs, and these all get categorized as malicious code. However, these are typically backdoors or programs such as Backorifice or Tiny or whatever the major Trojan horse programs are today. There's several well-known Trojan horse programs, and that's all covered in the Certified Ethical Hacking materials. We go over those step by step in there. And the last one is viruses. This is just malicious code. Now, it really doesn't make a difference if it's a virus or not, but if your Outlook settings that you would normally use to read your mail, if you have those settings to auto preview messages, that could actually auto execute a virus. So it's more of a configuration inconsistency or a weakness that would allow that behavior to happen. And so the moral of the story here is there are configuration weaknesses because security administrators and network administrators are working independently of each other rather than working together, so things get overlooked. Alright, the next section is human error and malice. Simply defined, you have to decide if something happened, if a normal security occurrence on your network happened, you have to decide if it was an accident, if it was just ignorance, people didn't know any better, or perhaps they were overworked, didn't see something, didn't understand something, and it was due to their workload. For example, people rushing to reply to emails, for example, and they accidentally hit reply all instead of reply. And so they disclose some information or reply inappropriately to an email when they shouldn't have. So is there malicious intent? You have to look at these in the scenario-based questions that we'll discuss not only throughout this course, but also in your practice exams and in real life. You have to decide if there's malicious intent. So you have to look for things like dishonesty. Is someone really being honest with you? Did someone ever try to impersonate someone else. Well, if you've ever worked at a help desk, you'll understand how common that is for a user to try to reset a password for another user's account. Then you have the classic disgruntled employee. Whenever an employee is leaving a company, you always have to ask yourself, did the person leave on